formula. Bless you. It's in the same section. The answers will be simplified using the rules that we learned about. Okay, so I'm going to say that this is a point A, and this is a point B, and this is a segment that connects them, and this is the line segment, and I would like to determine this distance. Point A has coordinates x1 comma y1 because it's my first point, and B has coordinates x2 comma y2 because it's my second point. In order to find this distance between those two, I will form a right triangle, and I will try to determine this distance, which is one leg, and I will try to determine this distance, which is the other leg, and see what happens. No, I'm going to use the Pythagorean theorem. Yeah. So I'm going to say that the distance squared equals 1 leg squared, leg 1 squared plus leg 2 squared. So this is my leg 1 and this is my leg 2. Okay, so now can anyone tell us what is this? This point is x1, y1. So how much is this distance? x1. It's x1. If x1 happens to be 1, then this will be 1. But it's x1. How much is this? y1. Yeah, if it happens to be 5, then it's 5. Good. What about this one? What is this? It comes exactly. And what is this? Good. So now I can find the distance. I know this distance now. It's this minus this. So what do I denote that by? x2 minus x1. x2 minus x1 gives me that distance. What about this distance? y2 minus y1 will be that distance. Agreed? So then,
you can't associate the two.
you could, but I'm not interested in the slope of this. I'm interested in using the Pythagorean theorem in the right triangle, which says the hypotenuse squared is the leg squared plus the other leg squared. So then the distance squared equals x2 minus x1 squared plus y2 minus y1 squared. Since I'm not interested in d squared, but I'm interested in d, I will take the square root from both sides. We haven't really talked about this process yet, but I will in detail. So d equals the square root. I should put plus or minus, but we'll talk about that later. It's a distance, so it cannot be negative. So now please tell me if I'm allowed to simplify this. So this is the distance formula. But am I allowed to simplify it? Like the square root of this plus the square root of this? Say it again. Can I?
You can, right?
I cannot.
Oh, you cannot simplify.
Because it's the square root of a sum.
Yeah.
And we said the square root of a sum,
Oh, yeah.
the square root of a difference, only if it's a product or a ratio. Okay. So this is it. Now also, there is a point that is called the midpoint, denoted by M. And it's this point right here, right in the middle of the distance. It bisects, we say, the segment, the line segment between A and B into two pieces, two equal pieces. And the coordinates of the midpoint are the sum of the two x coordinates divided by 2. It's the average of x values, comma, the average of the y values. The coordinates of point M. So this point M right here in the middle, I will find it by adding the two x values and divided by 2, and that will be the x coordinate, this one right here. This will be the x-coordinate of M, and this will be the y-coordinate of M. By simply adding them up, I'm adding up x1 and x2 and divide by 2 to get this number. I'm adding up y1 and y2 and I divide by 2 to get this number. Now please pick two ordered pairs. Give me two ordered pairs that you can think of or you want to work with. So we can find the distance between those 2 points and find the midpoint. Just give me any two ordered pairs you would like to work with. 6, 10, very good. I'm going to put 6, negative 10, so we have some negatives in there as well. And the other point, whatever you want.
3 and 4.
Excellent. This is my x1, and this is my y1, and this is my x2, and this is my y2.
Now, does it matter which point is first or second?
It doesn't matter because the distance from me to you is the distance from you to me. It doesn't matter which one you consider your starting point. Very good. So then the distance will be between these 2 points. I write the formula first. x2 minus x1 squared plus y2 minus y1 squared. And I write underneath those. x2, I write 3 underneath. x1, I write 6 under. y2, I write 4. And y1, I write negative 10. It is true that you will never write that the distance equals the square of negative 57, right? Because this is a positive number because it's squared. Then it's an addition, and this is another positive number because it's squared. You will never write something like this, correct?
So it always has to be
Right, right. Good. I'm making a point because I would like not to see that on the next test. Good. So now let's perform the calculations. How much is 3 minus 6? How much is negative 3 squared? Perfect. Plus. Excellent. 4 minus negative 10.
negative 6.
4 minus negative 10.
Oh.
It's 14. Just leave it alone as 14 squared. That's fine. And now we can rewrite. So D equals the square root of 9 plus, what is 14 squared? Thank you very much. So when I add 9 to 196, I have the square root of, is it 20, I'm going to have to take it aside and see if I can simplify in any way. So I simplify by, I divide by 5 and then 41. Nothing. I cannot do anything. This is the exact. If you want an approximation, you put in the graphing calculator. You approximate the square root. I put it in the square root of 205. And I get 14.32 approximately. But this is the exact. This is an approximation. Now the midpoint. Can anyone add those two x values for us? 9. 9 divided by 2. Perfect. Can anyone add these two numbers for us? Negative 6 divided by 2. So we found the distance between the 2 points that we picked, the square of 205, or roughly 14.32 units, and we found the midpoint of the line segment between the 2 points that we picked, which is the point that will bisect, will divide the entire line into 2 equal parts. This completes sections 10.1 through 10.3. In section 10.